Hi guys, in this video I'm going to be going over the quiz solutions for this Year 11 advanced quiz on trig equations, trig identities, and introduction to calculuses as well. So we'll just make our way right into it. Starting with this first question, we want to find the exact value of cos pi over 4 plus cos 2 pi over 3. Some students find it helpful to first of all change these radians into degrees. So we'll start off with that. So pi over 4 radians can be written as cos 45 degrees. And cos 2 pi over 3 can be written as cos 120 degrees. Now that we have that, we can find the exact value of each of those. These exact values can either just be remembered or using these special triangles that are shown on the reference sheet. So cos of 45 degrees we find to be 1 over root 2. And cos 120 degrees, that is the same as negative cos 60 degrees. We say it's 60 degrees because we can see that we're looking in the second quadrant. We'll do 180 minus 120, so it's 60 degrees. And as we know, cos is negative in the second quadrant, so that's why we say it's negative 60. So from that, we have 1 over root 2 again, and then so negative cos 60 is 1 over 2, so negative cos 60 will be negative 1 over 2. This can be then simplified to be 1 over root 2 minus 1 over 2. And what we should look to do from here as well is then put these fractions into one fraction. So we'll subtract these two fractions. So top left times bottom right is 2. Bottom left times top right is root 2. And then multiplying the two denominators, we have 2 root 2. Now we can leave it as that, although we typically do like to rationalize our denominators where possible. So to do that, we'll multiply both the top and bottom by root 2. And when we do that, we have 2 times root 2, which is 2 root 2. Root 2 times root 2, which is minus 2. And then on the bottom, we have 2 times root 2 times root 2. Well, the root 2 times root 2 is 2. So 2 times 2 is 4. And then we can look to cancel things out as well. So we'll cancel out all our 2's, leaving us with root 2 minus 1 over 2. So the key bit to this question is making sure that we know the exact values for these. So knowing that cos 45 equals 1 over root 2, cos 120 can be rewritten as negative cos 60, which is negative 1 over 2, and then subtracting two fractions together, rationalize the denominator whenever we can. Going into the next question, we want to consider the function 2 cos x. On the number plane above, we want to sketch the function for the domain negative 2 pi to 2 pi. So what we'll do is might as well start off by setting these points. We have negative 2 pi and pi, meaning that this is going to be pi, this is going to be pi, and then in between these points is going to be pi over 2 and 3 pi over 2. It's always good to consider these points when you're sketching trig graphs, because these are where the main important points lie on each of these graphs. So what we also need to do is think about what the range is going to be. Normally, as we know, the cos graphs are between 1 and negative 1, but because we have the 2 sitting in front of it, we now know that it's going to be between 2 and negative 2. So we'll say that we got 2, we have negative 2, and then from that, we can now start plotting what we call the anchor points, or what I call the anchor points. So think about the positive side first of all. Cos 0, cos starts at 1 normally, but now we're going to be starting at 2, and then it goes down. So at cos pi over 2 is 0, and then cos pi is normally negative 1, but now it's negative 2, and then going back up here, and then here. So thinking about the 5 anchor points for cos, and how that can change based on the different transformations. And then we'll just draw a nice curve, more or less going through each of those. Doesn't need to be super accurate, we just need to be nice and neat. And then think about the negative side, because we want to sketch from negative 2 pi to 2 pi, so not just the positive side. Again, we'll think about these anchor points, and you remember that it just repeats itself. So this will be 0, this will be negative, this will be 0, and this will be positive. And so again, continuing this curve to be something like that. And then there we go. We just got the normal cos graph, except instead of being between 1 and -1, we are now between 2 and -2. So therefore, state the domain and the range of the function. Admittedly, I did word this question not very well, because seeing that we sketched between -2 pi to pi, you could argue that the domain is between -2 pi and 2 pi. But if we were just considering the function 2 cos x, I would say that the domain is from -infinity to infinity. So we'll say -infinity to infinity. And as for the range, we can see in our graph, is going between -2 and 2. So -2 and 2. Realizing these are square brackets because the function can actually equal -2 and 2, whereas these are curved brackets because obviously you can't ever actually equal infinity. Going into these next questions, and this next page is all about solving trig equations. And each of these questions have like a different trick to it. So to start us off, whenever we're solving a trig equation, we always need to get, we want to get the trig ratio by itself. So in this case, we're going to -1 on both sides. We have 2 cos x equals -1, and then we'll divide by 2. So we have cos x equals -1/2. So now that we have that, we now have cos x by itself, so we can go to the next step in thinking, well, what quadrants are our solutions going to be in? So thinking about our ASTC, we're looking where cos is negative, meaning that we're looking at the second and the third quadrants. Because remember, A is saying that they're all positive, and the fourth quadrant is where cos is positive. We're looking at when it's negative. So therefore, we're looking for the third quadrant and the fourth quadrant. Okay? So now that we have those, even though not this third and fourth, my mistake, second and third. Anyway, my mistake. So now that we've identified that our solutions are going to be in the second and third quadrant, we still find it useful to find the answer that's in the first quadrant to serve as what I call the key. Even though the answer in the first quadrant isn't going to be helpful for us, isn't going to be a solution, we find it to be helpful. So the answer in the first quadrant, we're trying to think of cos what equals 1/2. Cos 60 equals 1/2. And then from that, now we can use that 60, which I'm going to call the key. If we're looking in the second quadrant, the answer is going to be 180 minus that key. So 180 minus 60, which is a cos 120, which equals -1/2. And in the third quadrant, we have cos, what we do in the third quadrant, we do 180 plus that key. So it's going to be 240 degrees, which is -1/2. So from this, we can say that my two solutions are going to be 120 degrees and 240 degrees. However, we don't want our answer to be in degrees, and this is an important thing to realize. The question wasn't asking me to find the solutions between 0 and 360 degrees. Instead, the question was asking me to find the answer between 0 and 2 pi, meaning that I have to convert both of these angles into radians. So the way that we do that, of course, is we'll just divide by 180 and put a pi in there. So 120 degrees is 2 pi over 3. And 240 degrees is 4 pi over 3. And there's your two solutions. Going into the next question, couple of tricks here. First of all, we have something that has multiple trig ratios in there, which is a bit tricky. But we also see that the domain that we're trying to find the solutions for is between -pi and pi, rather than 0 and 2 pi. So we also need to make some adjustments for that. But first of all, let's move this around because we can't really solve these trig equations when we have more than one ratio. let's first of all try to get rid of that root 3. So we have sine x equals root 3 cos x. And then once we have sine x equals root 3 over cos x, we can then divide by cos x to get sine x over cos x equals root 3, which means we have tan x equals root 3, using the identity tan x equals sine x over cos x. So now that we're now looking when tan is a positive number. So again, let's bring up our ASTC. And we're looking where tan is positive. So we're looking here and here where tan is positive. So we're looking in the first quadrant and the third quadrant. So from this, we've got looking at our first quadrant. Again, we want to find what our key is. In this case, that key is actually also going to be an answer. So we're thinking tan what equals root 3. Again, going back to our exact ratios, tan 60 equals root 3. And then using that key, I can now find for the third quadrant, I'm going to do tan 180 plus 60, which is tan 240 degrees, equals root 3. And so, therefore, we have our answers are going to be x equals 60 degrees and 240 degrees. Now, before we go and convert these into radians, we need to realize that the domain in which we're trying to find our solutions is between negative 180 to 180 degrees. And we notice, okay, well, the 60 degrees is fitting in there. However, the 240 degrees doesn't fit in there. So that's actually not going to be a solution. That doesn't mean our only answer is 60, though. We can also consider there might be some negative answers. And what we can do is, looking at this 240 degrees, what we might remember is we can add and subtract any amount of 360 degrees and it will still work. So I'm going to keep the 60 degrees as it is, but because that 240 degrees is outside our domain, I'm going to subtract 360 degrees from that to get negative 120 degrees. And then we see that 60 degrees is in that domain, and negative 120 degrees is also within that domain. So now we found our two solutions. So we're just noticing that 240 is outside that domain. So it's doing 240 minus 360, which equals negative 120, which does fit within that domain. Remember, you can add and subtract 360 just to see what else is in the domain. And then so now that we have that, there's our two solutions, but again, we need to solve in radians. So therefore, x is equal to pi over 3 and negative 2 pi over 3. And there's our two solutions. Looking at this last one, again, we need the sign by itself. So we'll have sine 2x equals 1 over 2. And what we can't do from here is then just divide by 2 again, because that 2 is kind of linked with the x. Okay? So what we're going to do is just solve like we normally would, and then make some considerations at the end. So here we're looking when sine is positive. So we're looking at the first and second quadrants. So the first solution is we'll have sine 30 equals a half. And in the second quadrant, we're looking at sine 150 equals a half. So we can say that 2x, because remember we're solving for 2x, not for x. 2x equals 30 degrees and 150 degrees. But because we're solving for 2x, that means the domain in which we're solving right now is between 0 and 720 degrees. So what we can do is consider, well, there might be some more solutions that are greater than 360 degrees. And like I said with the previous question, what we can do is just add or subtract any amount of 360 degrees to find more solutions. So we have 390 degrees and we have 510 degrees. Each of these came from, well, 390 is just 30 plus 360, and 510 is just 150 plus 360. The reason why we need to do that is because even though 390 and 510 are greater than 360, which is what we're looking to find. We've found this for 2x. So what I can now do is divide each of these answers by 2. So I then have 15 degrees, 75 degrees, 195 degrees, and 255 degrees. So this is for when x is between 360 degrees. Okay? So the reason why we had to do that is because we were solving for 2x, and thereby we had to halve all our answers. That means some answers that were originally out of domain, once we halve them, come into our domain. And again, lastly, what we need to do is make sure that we change these into radians. So therefore, my solutions in radians are going to be pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12, I believe. And there we go. So going into our next question, we're looking at a trig identity question where we just need to show that this left-hand side equals this right-hand side, and we need to use a couple of our trig identities. So typically what we want to do is look at which side. We'll start with one side and try to move it across, so manipulate it until it equals the other side. And generally we want to choose the side that will have more things that we can work with. So in this case, I'm going to work with the left-hand side, and I'm going to start moving things around until it equals the right-hand side. The reason why I'm choosing the left-hand side is because I have tan and cot, and I know some identities involving tan and cot. Tan, first of all, is equal to sine theta over cos theta. And therefore, cot, which is the reciprocal of tan, is cos theta over sine theta. So I've changed this tan to be sine over cos, and this cot to be cos over sine. Now that I have these two fractions, I'll then look to add these two fractions. So the way that I do this, top left times bottom right. So sine theta times sine theta is sine squared theta. And then bottom left times the top right. So that's cos squared theta. And that's over cos theta sine theta. I multiplied the two denominators. Now that we have that, we see sine squared theta plus cos squared theta, and we should immediately realize that that's the Pythagorean identity. So sine squared theta plus cos squared theta just equals 1. So we have 1 over cos theta sine theta. From here, we can write this as this. We can split this fraction to be 1 over cos theta times 1 over sine theta. 1 over cos is sec theta, 1 over sine is cosec theta, and there we go. We've found what we needed to find right at the start. That equals the right-hand side, so we're good to go. So with these trig identity questions, remember you always want to start with one side, keep manipulating and moving around using the other trig identities you know until you get to the right side, and that answers your question. So that's it for the trig part of this quiz. We're now going to look at the calculus part of this quiz. And this first question is kind of like a breakdown of the differentiating by first principles process. So we consider the function fx equals 2x squared minus 7x plus 3. We want to show that fx plus h equals that. All right? Fx plus h, remember using our what the function notation is if we're finding fx plus h, that means we're going to replace all our x's with x plus h. So every time we saw an x in the original, we're now going to be writing x plus h. And from here, we can then expand. So we have 2, and then x squared plus 2xh plus h squared. I'm just going to keep them in the brackets for a second because I've expanded the squared, but I haven't multiplied everything by 2 yet. And then now I'll do the expanding with 2. So we have 2x squared plus 4xh plus 2h squared minus 7x minus 7h plus 3, which is exactly what we're looking for. So there we go. So now we need to show that the thing that we just found minus the original function equals this. So we can say that this is going to equal 2x squared plus 4xh plus 2h squared minus 7x minus 7h plus 3 minus, and then this is really important that when we're doing the minus fx, we use brackets because, well, you'll see why in a second. I can't just, if I wrote it without brackets, when I expand these brackets, I'm going to have negative 2x squared, but I'm going to have a plus 7x and minus 3. If I didn't write those brackets, then these will be wrong, and you'll see why that's important. So once I just write this whole thing again, so doing the expanding now, note that we have, like I said, minus minus, so it becomes a plus, and then this will be minus 3. The reason why this is very important is now that we're going to look, as we do first principles questions, a lot of things will cancel out. So we have 2x squared minus 2x squared. We have minus 7x and 7x. We have plus 3 and minus 3. So this is why the expanding was important and keeping those brackets, because if this was a plus 3, that would equal 6. They wouldn't cancel away. And if this remained as a negative 7, I would have negative 7h minus 7h. Minus 7x minus 7x, and that'll be minus 14x. So by design, is first principles, lots of things are going to cancel out. And then what's left over is just the 4xh plus the 2h squared minus 7h, which again is what we're trying to find. So lastly, we now, hence using the first principles formula, differentiate by first principles. So we're going to say that f dash x equals lim as h approaches 0 of all this. So we have 4xh plus 2h squared minus 7h, which is what we found in the previous question. And this is over h. Going from here, we can cancel out one of the h's across the board, leaving me with, as lim h approaches 0, 4x plus 2h minus 7. So what we're trying to do here is we're trying to make h equals 0. And on the previous step, we weren't able to do that because if I made h equals 0, I'd be dividing by 0, which obviously is a problem. But by doing the previous steps, I was able to express this numerator each with a h. So all the h's cancel out, meaning there's nothing stopping me from now just substituting h equals 0. So this will equal 4x plus 2 times 0 minus 7. 2 times 0 just goes away, which equals 4x minus 7. And that is the derivative. And that's differentiated by first principles. Now, of course, as we know, we have shorter methods of differentiation. And you could have taken 2 seconds to do, well, 2 times 2 is 4x, and then that goes away, and the 3 goes away, and then that's it. And yes, we can differentiate in 2 seconds, but the question was specifically asking us to differentiate by first principles, which is like the way to differentiate. All our rules of differentiation are just shortcuts or patterns that we've noticed of the first principles method. Anyway, going to these next questions, we're now just asking to differentiate a few more things. And because it's not asking us to do by first principles, we don't need to. And doing this question with first principles would be tragic. So here we have a function where we've got x's on the top and the bottom. So it immediately tells us that we need to use the quotient rule. So using the quotient rule, we're going to say that u equals x squared plus 3. And therefore u dash equals 2x. And as for v, v is the denominator. So we have x minus 1. And that means v dash is just equal to 1. Now looking at our reference sheet, or just by knowing, therefore we can say that f dash x is going to equal, and the order here does matter, it's going to equal u dash times v minus u times v dash over v squared. So you can just refer to your reference sheet for that. So we're going to have 2x times x minus 1 minus 1 times x squared plus 3. Again, making sure that we're considering the brackets. We're doing 1 times x squared plus 3, but we're minusing the whole thing. and that's over v squared. So v is x minus 1, so we have x minus 1 all squared. Now, technically, there we've differentiated, so we can just leave it there. But we might as well just do a bit of expanding if we can. So from here, we have 2x squared minus 2x minus x squared minus 3 over x squared minus 2x plus 1. And then we can see that those x's cancel out a little bit. So we have x squared, 2x squared minus x squared is x squared, minus 2x minus 3 over x squared minus 2x plus 1. And of course, what you can't just do from here is just say, well, that these cancel out, these cancel out. That's not how it works. Because if I'm going to cancel out the x squares, that means that has to have an x squared as well. And that needs to have an x squared as well. And that needs to have an x squared and so on. So we just leave it there. But technically, you could just leave it there. Going into our next question. So you might see this and immediately think quotient rule again, but what we can use is the index laws to make things a bit quicker. So we can rewrite fx to be 3 times x to the power of negative 2 plus 5x squared. And so with that, we can now just do our normal differentiation because there's nothing stopping us from doing that anymore. So negative 2 times 3 is negative 6. And then when we subtract the power by 1, make sure you don't make it negative 1. It'll be negative 3. And then this will be plus 10x. And then that's your answer. But of course, we could just use our index laws to get rid of the negative index. So we have negative 6 over x cubed plus 10x. So nothing too crazy there. It's more just realizing that 3 over x squared can be written as 3x to the power of negative 2. Looking at this next question, we want to find the equation of the tangent to the curve this at the point where x equals negative 1. To find the equation of the tangent, or the equation of any line, you should be thinking the point gradient formula. So your y minus y1 equals m x minus x1. We already have the x value. All we need to do now is find the gradient and a y value. And the way that we can find both of those, well, the gradient, we should know the gradient can be found by differentiation. And the y value can be found by just subbing x equal into the original. So let's first of all start by doing the differentiation. So y dash will equal, we'll bring down the 4 using our chain rule. So bring down the 4, we differentiate what's inside, which is just 2, and bring that out. Then we leave the bracket as the same and decrease the power by 1. And this can be written as 8 2x plus 1 cubed. So now that we have our derivative, that's going to help us find the gradient. So therefore, if x equals negative 1, we'll get y. First of all, we need to find the y value. So if we sub in x equals negative 1 into here, we have 2 times negative 1, which is negative 2. Negative 2 plus 1 is negative 1. And then negative 1 to the power of 4 is just 1. And then subbing it into y dash, we have 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Negative 1 to the power of 3 is negative 1. And then 8 times negative 1 is negative 8. So that's just a quick substitution, and you can go through that process yourself. But we get these values. So from here, this is my x value. This is my y value. And this is going to be my gradient. So therefore, putting this into the point gradient formula, I have y minus 1 equals negative 8 x plus 1. Now, of course, it's plus 1 because our x is negative 1. So you're doing x minus negative 1, so that's x plus 1. And then technically you're done from here, but we might as well rearrange into point gradient formula, gradient intercept formula, gradient intercept form or general form, however it is really asked. So I've just done the expansion, and then I'll move the 1 over. So I have y equals negative 8x minus 7. Or we could rewrite this as, by adding those over, we could also write this as 8x plus y plus 7 equals 0 if I wanted in my general form. Either way is going to be fine. Going into the last page of the quiz, we have a person stands on top of a wall above ground level and throws the ball into the air. The height h of the ball to the ground after t seconds is given by this equation. So this is just an application of calculus. So how tall is the wall the person is standing on? we're told that it's thrown on top of a wall. So what we're really asking is, what is the initial height of the ball? Initial meaning t equals 0. So if t equals 0, h would equal 9. So therefore, the wall is 9 meters tall. Okay. It doesn't specifically say meters in the question. I should have written that as well. So the height of the ball from the ground, I should say in meters, which makes sense. So the next question is saying, well, when does the ball reach its maximum height, and what is the maximum height? So if we look at this is going to be a concave down parabola, and so we want to find that the top of that parabola. The way that we can do that is by differentiating and making it equal 0. So when we differentiate this, so dh dt is going to equal negative 2t plus 8. And so we want to make this equal 0. So therefore we have 0 equals negative 2t plus 8. And then just solving this as usual. So negative 8 equals negative 2t. T equals 4. So therefore, is going to be its maximum height after 4 seconds. But the question is also asking, what is that maximum height? So if t equals 4, summing that back into the original equation, I'll get h equals 25. I don't want to substitute into the derivative. That doesn't help me. I'm just going to find 0. I want to find the height, which is represented by h. So therefore, after 4 seconds, it is 25 meters high. And then, so when does the ball hit the ground? Well, when the ball hits the ground is when h equals 0. So going back to the original equation, I have 0 equals negative t squared plus 8t plus 9. And now this is a non-monic quadratic. So what I'm just going to do is multiply everything by negative 1, just so I can make it monic, because that makes solving things a whole lot easier. And so now just doing my PSF, factorizing the quadratic, think of two numbers that multiply to be negative 1 that add to be negative 8. So that's going to be t minus 9 and t plus 1. So therefore I get t equals negative 1 or 9. Now obviously negative 1 isn't going to be an option, because that's like going back in time. So we get t equals 9. So therefore the ball hits the ground at 9 seconds. And to kind of imagine what's happening in this situation now, after t equals 0, so after 0 seconds, the ball is 9 meters above the ground, because that's the wall that we're standing on. It's thrown into the air. 4 seconds later, it's reached its highest height. And then for the next 5 seconds afterwards, it's falling down until it hits the ground. And then this last question, for what values of x do the graphs this and that have the same gradient? So same gradient is the key bit here. Gradient, as we know, is found by the derivatives, and same meaning equal. So essentially what we're trying to do is, if we differentiate both of these functions, and then just equate their derivatives, that's the equation that we're going to end up trying to solve. So given y equals x cubed, y dash will equal 3x squared. And given y equals x cubed plus x squared plus 4x minus 1, I'll get y dash equals 3x squared plus 2x plus 4. So therefore, like I said, I'm trying to find when they have the same gradient. Well, these are their gradient functions, so I'm going to make their gradient functions equal. So 3x squared equals 3x squared plus 2x plus 4. And now just start solving. So I'll subtract 3x squared over, leaving me with just the 3x squares will cancel out. So I've got 2x plus 4. Take the 4 over. And then x equals negative 2. And that is the only value for where the gradients are the same. And if you were to put this into Desmos or something, when x equals negative 2, you'll see that they have the same slope. The question isn't asking us to find that gradient, although we could easily do that by substituting x equals -2 into either one of these gradient functions. But basically what it comes down to is differentiating them and then solving them simultaneously to find any values of x. Anyway, that's the end of the quiz. Hopefully this video has been helpful. And if you have any more questions on the trig or calculus, just be sure to ask. Thanks for watching.